The third one, the fourth one that I'm going to give you, you could have a discussion with your friends without even having to know any science. You know we're in a universe that has a beginning because you can't be in any other kind of universe and talk about it because of this law, the law of infinite regress. Imagine we're getting ready to join the police academy, and I get you on a racetrack, and I put you at the starting line. We're going to do a PT test, physical training test. So I'm going to get you on that race, on that start line, and we're going to get you all to run 100 yards. So you look downfield, and let's pretend like it's not a circular track. Let's pretend like it's a straight track, but you can see the 100-yard line, the common finish, right? All you have to do is be the first person to get to the 100-yard line. I get all of you on the track. I have you set your blocks. You're ready to go. I have you put your feet in your blocks. Everything's cool. I raise my starter's pistol to start this race. But the second before I pull the trigger, I tell you, stop. Sorry, I need you to move your blocks back 6 inches. You're like, dang, almost got started. Okay, I'll move my blocks back 6 inches. You're all ready to go again, ready to start the race. And I say, stop. Move your blocks back 6 inches. And every time I'm about to start this race, every time you're set and about to go, I stop you before you can start, and I set you back 6 inches. I keep on moving you back 6 inches. If I did that forever, would you ever reach the 100-yard line? Now, we're not on a circular track. Okay, we're on a straight track. Would you ever reach the 100-yard line? No. See, without a firm start, without a beginning to this race, you can't reach the finish line. Finish lines can only be reached if you have a beginning. But if the finish line is not the 100-yard line, if the finish line is today, it's right now, it's me telling you about this. If this is the finish line, we can't get to today unless there's a beginning to time. Follow me? If there's no start to that racetrack, we can't get to this finish line. We can't be here today to talk about this universe unless we're in a universe that has a beginning. Does that make sense? So even philosophically, before you look at any of the physical evidence, we have good reason to believe we're in a universe that has a beginning. Now look, I gave you 4 pieces, briefly. There's a great organization called Reasons to Believe. And I think it's just www. Oops, I just went black screen. Sorry, guys. I think it's just www.reasons.org. Great guys. Fuzz Rana is a astrophysicist. Not Fuzz Rana. Hugh Ross. And Jeff Zwirink is also an astrophysicist. And Fuzz Rana is a molecular biologist. These guys are all science folks. And they actually have been formulating a list. They have, I think, 30, now they probably have like closer to 40 pieces of evidence right now that we are in a universe that has a beginning. So if I was to make a case for this in front of a jury and I said, hey, do I have good reason to believe we're in a universe that has a beginning? Well, yeah, I think I've got 4 really good pieces of evidence I can describe quickly to a jury. But not only that, these all point to the same most reasonable inference. They point to the same thing. We're in a universe with a beginning. And not only that, if I could add all the other stuff, now I think this is the most reasonable inference. All this stuff points to a universe with a beginning. So then the question becomes, well, how did this happen? How can this begin? What are the alternatives that are offered? Have you ever heard of multiverse theories? Maybe science has got a way of explaining this with multiverse theories. Have you ever heard of a guy named Alexander Vilenkin? Prominent, he's a professor at Tufts University, an astrophysicist. He's really smart. Have you ever heard of quantum theories? I'm going to explain them to you in a minute. Here's a guy who, Lawrence Krauss, I think he's kind of funny. He's debated William Lane Craig a couple of times. He is a professor, a physicist at Arizona State University. Let me show you what they're offering. Both are offering something similar to this. Imagine that the universe, is not what you think it was. Imagine instead a big pot of boiling water. See what 9 years of art school can do for you? That's why you should go. Okay, you have a big pot of boiling water. And in this boiling water, what happens when you boil water, by the way? Let's put some water in here. Pot of boiling water. What happens when you boil water? Bubbles. Bubble up from the bottom. They usually start off really small. They get bigger as they go up. And the top, the activity in the top of the boiling water is pretty active, right? Because all these bubbles are colliding. They start off small. What if our universe is really just one of these bubbles in a huge quantum environment? In quantum physics, we don't always know why things emerge, why things pop into existence. Quantum particles, sometimes at very, very small scale, it's different. The rules are different at the small scale of quantum physics than they are at the macro scale. So the question is, couldn't universes come into existence at the quantum level in this quantum environment? And our universe does have a beginning, but it's in an infinitely old pot of water that's eternal. Is that possible? That's why we call it a multiverse, because there's all kinds of bubbles in this pot. There's some problems with this theory. The first problem is, if this was the case, what happens is at some point the bubbles collide. We ought to see, and by the way, if it's infinitely old, that should have happened an infinite number of times by now. So how do I avoid the problem that I have no evidence that any universes have ever collided? We've never seen any evidence of any other universe colliding with ours. Well, maybe the pot is actually getting bigger also. And it's actually growing at a rate that is faster than the growing of the bubbles. So they can never touch each other because this growth is actually bigger than the bubble growth. Make sense? I've avoided the problem now. But Vilenkin, who's a proponent of multiverse theory, says that won't work for you. Vilenkin says this. He says if there's any evidence of expansion, then that had a beginning also. So if this is expanding, then it has a beginning also. And the question becomes then, well, where did the pot come from? Where did the quantum environment come from? But there's a bigger problem with these theories. Because remember, we're saying that everything, all space, time, and matter came from nothing. And this pot of water is not nothing. It's something. So Lawrence Krauss, he said this on the Colbert Show. I recorded it because I thought it was pretty cool. He said, physics has changed what we mean by nothing. Empty space is a boiling, bubbling brew of virtual particles popping in and out of existence. If you wait long enough, that kind of nothing will always produce particles. So he wants to redefine nothing, but he's cheating. Look what he just said. He said empty space is now this. Well, wait a minute. Space is not nothing. Space is one of the three things we defined as something. Space, time, and matter. Oh, you're going to start with space? Where did space come from? Oh, no explanation for that. There's the problem. We know space has a beginning. Who began it? He wants to steal space and start with it. Then he says, if you wait long enough, oh, now you've got time? You can wait? So now you stole space and time. Oh, and also, you know, they've got energy. Oh, now you have stuff? So now you've got everything we're trying to explain. You're starting with everything we started trying to explain. This doesn't explain anything because it starts with something you can't explain. See the problem? These things, well, here's what Krauss does. Krauss is kind of like when you come home from a long day at school and you open up the refrigerator to your mom's house, right, your dad's house, and you see the refrigerator is filled with this kind of food. And it's all so water and fruit and vegetables. Asparagus isn't there, for crying out loud. What's the first thing you say when you see something like that? There's nothing to eat in here. Well, yeah, because there's nothing you want. You have to redefine that. There is something in there, just not what you like. There's something in here, just not what Lawrence likes. We got to explain how this something came from. Where did that come from? That's the problem. So in the end, multiverse theories and quantum theories just don't have an adequate explanation. And by the way, these guys are fighting with each other constantly about these theories because they don't like each other's theories. Lawrence Krauss does not agree with Vilenkin. Vilenkin does not agree with Lawrence Krauss.